Mercury isn't supposed to be like this. It's the closest planet to the sun, a place where metal can melt in the daytime and freeze solid at night. A world that should have been destroyed billions of years ago. And yet, Mercury is still here. But surviving the sun isn't the strangest thing about it. Mercury breaks the rules of time. It breaks the rules of planetary formation, and it may be the most misunderstood planet in our solar system. Mercury orbits just 58 million kilometers from the sun. From its surface, the sun would appear more than 3 times larger than it does from Earth. The light wouldn't feel warm, it would feel violent. Daytime temperatures climb to around 430 degrees Celsius, hot enough to melt. Hot enough to turn the surface into a blazing desert of rock and shadow. But when the sun sets, something unbelievable happens. The temperature collapses to -180 degrees Celsius. In just a few hours, Mercury transforms from a furnace into a frozen wasteland. How can one planet experience both extremes? The answer is simple. Mercury has almost no atmosphere, no thick layer of gas to trap heat, no protective shield to soften the sun's radiation. Whatever heat it receives during the day escapes straight back into space at night. But temperature isn't the only rule Mercury breaks. Time itself behaves differently there. On Earth, a day lasts 24 hours. On Mercury, one sunrise to the next takes 176 Earth days. That's longer than its entire year. A year on Mercury is just 88 Earth days, which means the planet orbits the sun twice before experiencing a single full day. This strange rhythm happens because Mercury is locked in what scientists call a 3-to-2 resonance. For every 3 times it rotates on its axis, it completes 2 trips around the sun. No other planet in the solar system moves exactly like this. And if you stood on Mercury's surface, you would witness something impossible. The sun would rise over the horizon, slow down, stop, move backward, and then rise again. A double sunrise. On Mercury, even the sky doesn't follow the rules. But the biggest mystery lies beneath the surface. Mercury has an enormous iron core. Compared to its size, it's massive. Nearly 85% of the planet's radius is just metallic core. For comparison, Earth's core makes up only about half of its radius. Mercury's almost all metal, wrapped in a thin, rocky shell. Why would a planet so small have such a giant metallic heart? Data from NASA's Messenger mission revealed just how unusual Mercury really is. Its density suggests that something dramatic happened early in its history. One theory says Mercury was once much larger. Then a massive collision stripped away most of its outer layers, leaving behind the heavy iron center. Another theory suggests that the young sun's intense radiation blasted away the lighter materials before the planet fully formed. Either way, Mercury shouldn't look like this, and it's still changing. Mercury is slowly shrinking. As its giant core cools over billions of years, the planet contracts, the surface wrinkles and cracks. Massive cliffs stretch for hundreds of kilometers, formed as the crust compresses. It's like watching a planet age in real time. And yet, despite its size and slow rotation, Mercury still has a magnetic field. Small planets are supposed to lose their magnetic fields quickly, but Mercury hasn't. Its oversized core may still be partially molten, generating a weak but real magnetic shield. Once again, Mercury refuses to behave the way it should. Too close to the sun. A day longer than its year. A metallic heart that dominates the planet. A surface that is shrinking. A magnetic field that shouldn't exist. Mercury doesn't just orbit the sun. It defies expectations. It breaks the rules. And if the smallest planet in our solar system can be this strange, imagine what else is waiting out there in the dark.